Hello everyone, welcome to my YouTube channel. This is Ali and I'm very glad to see you in here. It's around 2 months and I very miss you and I hope you have a good time in these days. So before we getting started and in a short summary, I'm going to tell you what we're going to do and what is the approach from now on. Okay, we're going to start with the concept that's how we can get into in the cyber security field without the any advertise that's like that. Hey guys, I'm going to learn Waibani in 2 days, in 2 hours, and something like this. Okay. I'm going to show you, let's check the, I'm going to tell you what is my main resource and we're going to work on it. I'm going to create a repository about it and we're going to work on that. And I'm very glad to start this repository. The repository that I'm going to work on it, let's get on the desktop and I'm going to show you what exactly I mean. Okay, as you can see in here, I'm going to use this repository that is learn security materials and I'm very glad to found this repository, this markdown file that is great. You can see the video, but it is in Persian language. You can use the subtitle and see it carefully. And I think, and you can use this one. Let's show you exactly what happened. This is the full mind map, show you all the steps that you should learn and you should know about it, like before even starting. And this is great. I suggest you to find this. How I find this, I'm going to the pull request and in here, some guy, thanks to him, provide a, how can I tell that? Provide a visualization for this and I'm very happy to find this. You can see in here and as you can see, this is the file. We can open that in new. I'm going to copy this and I'm going to show you new notepad and okay, I'm going to put this in the notes that we take on the video. I think the video is getting too long and let's get back in here and let's get back in the file that is the security materials. And yes, I'm going to start and I'm getting started with the basic OS and networking. And I'm going to start with network plus study guide and Linux Bible. I'm going to these two and each chapter that I've finished, I'm going to post a blog post about it, about each chapter. And after that, I'm going to record a video about that specific blog post and we're going to learn this concept together. And we're going to continue read other books, other resources, and even we're going to work on the free online courses and classes specific to Pound College that is great and very, very, very helpful. And I don't work on it. I just get some introduced with it, but I don't start any courses. We're going to work on this. And I think everything is great. So I'm going to share this one source. Sorry for the source and the visualization of the source. Okay, this is it. After I finish that means I'm going to finish this and I'm going to open up the first chapter of the network. And this first chapter that is related to the security field. Okay, we don't need to learn how to know physical. It's good to know that, but for now we skip it. I'm going to some concept that we really, really, really need to know about it. Okay, for today, I'm sorry for the time that I'm trying to tell you something. For today, we're going to start with the network, and the title of this video is Chapter 1 of Network, and plus the introduction and the guide to learn. And as we can see, we going to start with the basic OS and networking. After that, we're going to basic programming for the security. The author suggested the Python. We can learn it, or even we can learn other things. And after that, we're going to basic hacking, pen test, and exploitation. And we're going down. And we always going to solve the try hack me and anything related to it. Okay, guys, this is the chapter 1 of the network, and I'm going to share this. How can I tell that? I'm going to paste all the text in here in the notebook LLM, and then I'm going to talk about it on the mind map. And I think it's great. It's a great way to work and see what exactly and learn in a way that's very, very, very helpful. Okay, let's get started. When we talk about the network models, we should talk about the types of the network models. Okay, we have two types of the network models: OSI 7 layer and TCP/IP. Okay, if sorry, I don't want to. And the next one is common theme for the network models. We can talk about the powerful mental tools for diagnosing problems and a common language to describe the network. And if we wanted to talk about the biography of a model, it's a simplified representation of real things. Must have major function of a real item. Purpose is to guide for interconnecting networks. OSI is granddaddy from the ISO and TCP/IP works for TCP/IP protocol suite, and the knowledge aids troubleshooting. Okay, let's talk about the OSI 7-layer model. Each layer defines important functions. So let's get to the protocols and talk about the protocols. What is the protocols? Protocols is sets of rules, regulations, standards, and procedures. Protocols enable hardware, software function. Okay? OSI 7-layer is a modular design. Each layer trusts other layers from top to bottom. Is layer 7 is application, layer 6 is presentation, layer 5 is session, layer 4 is transport, and layer 3 is network, layer 2 is data link, and layer 1 is physical. Let's talk about each layer. Start from the layer 1 physical. Wait, the mind map. Okay. In the physical layer, the data moves around bits. Okay. The components like UTP cable, central box, UTP cable, and central box. What is exactly the central box? Each device that puts between the devices in the network, between the assets in the network, or move through the data from one to another. And we can tell that the central box can be hub or switch. The cabling is like the copper, fiber optics, and even radio waves. And in this layer, it doesn't care about data content. And the network interface is necessary for layer 1. And let's talk how data is transmitted. Data is going to transmit via the frames. Okay, let's get to the layer 2 data link. Okay, what's put in here? It's called NIC, Network Interface Card. Network Interface Card, it's an interface that plays between the PC and the network. And there is a unique identifier for this asset that called the MAC address. So let's talk about the MAC address. Never ever two NICs don't share same MAC address. Okay, and IEEE. This is the job of IEEE to assign the blocks, and MAC address is a hexadecimal notation, and first 6 digits is the OUI for the organizationally unique identifier, and last 6 digits is the device ID, the manufacturer's unique serial number. And for get all the MAC address, we can type the ifconfig space /all in Windows and IP space add for in the Linux. And after that, we know the MAC address is the physical address or physical addressing And the original name of the MAC address was the MAC 48, but for now, they called it EUI 48. Okay, let's get back in here and talk about the data transmission in the layer 2 data link. Sorry for the speed. I'm going to modify my speed in the speaking. And okay, let's talk about the data transmission. NIC sends and receives the binary data that we know that is something like the pulse, and data getting chopped into the frames. What is the frame? Frame is a container for the data that is chunk, or we can call it data chunk data. And the NIC is going to create and receive and read the frames. Same frame type needed to on the same network to data get through from one to another device. And let's talk about the continue. Let's talk about the frame structure. Okay? In the frame, we have some spinets, some ports that we should know about it. The first one is the MAC address of the destination. Another one is the MAC address of the source, and the type field that is the network technology, and another part is the data. And the last one is the FCS. We can call it frame check sequence, and it stands for the frame check sequence. What is it and how this works? Let's talk about it. The FCS use the CRC, cycle redundancy check, and verify this is going to verify the data integrity. This is just 4-byte line, and the NIC calculates the CRC on the send, and this destination NIC verifies CRC on the receive. And it's very great. Sorry, I don't know what happened in here. Okay, let's get back in here and okay. We talk about the frame structure, and let's tell that the NIC passes data to the device driver. After that, we know that frame is limited to 1500 bytes. Sorry. So let's talk about the central box rule. We told that the central box can be hall or switch. Let's see what we have in here. Okay, the hub is one device, a repeater, copies the frame to all the systems, and every NIC receives the frame. And the switch is a smarter device that filters traffic by the MAC address and sends frame only to the recipient's MAC. Okay? And after that, only one system can speak at the time. Okay? MAC address discovery. Let's about the ARP. What is the ARP? If MAC is unknown, NIC sends a broadcast frame that contains F, 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 etc. And broadcast contains a request for MAC using the IP address. And at the last, we have a complete frame movement flow. Okay, let's see what happened exactly in here. The sending OS hands the data to the NIC. Okay, NIC builds a frame as FCS, destination and source MAC address. NIC waits for the clear cable. In other words, waits there is no other connection in the cable. How can I tell that? In the connection. And then going to send the frame. And after that, frame going to the central box in the hub, copies to all assets in the switch, sent to the destination. And the receiving NIC checks the MAC address, process if it's match. And destination NIC will going to verify the FCS, and after that, destination NIC strip the framing hands data to the OS. And this is the flow of the frame movement in the layer 2. And after that, note that this is some exam tip. You can write it down. Any device that dealing with the MAC address is layer 2. Note that. And something interesting that I've read from the book, that is the NIC is layer 2 and layer 1. Note that. And the layer 2 provides DLC, data link control series, and in the another bullet, we going to talk about the 2 jobs of NIC. Okay, let's see what happened exactly here. NIC have 2 works. First one is LLC, logical link control, and another one is MAC, media access control. Let's talk about the LLC. In the LLC, talk to the OS via the device drivers, handles multiple network protocols, and provide a flow control. Okay? And in the media access control, creates an address, the frame. After that, going at the source and destination MAC address. After that, add and check the FCS and ensure frame is completeness. And in another word, ensure that frame is complete and send the frame to the network. And the only layer with sublayer. Layer 2 is the only layer that have sublayer. Let's get back in here and close this one and close this one either and get back in here. Let's talk about the layer 3. Okay. What was the layer 3 is the network. Okay. In the network, layer 3 network, we're going to handle the logical addressing. What is the logical addressing? We call it IP address. In this layer, large network breaks into subnets, okay? And containers called packets create an address in this layer. And Internet protocol is primary logical addressing protocol. And The IP ensures data reach to the destination. And each device has a unique IP address. IP address is a 4 8-bit numbers from 0 to 255. And no two systems on the same network share same IP. And configured by end user, routers connect subnets use IP addresses. IP address, which means the logical and MAC address is the physical. After that, the process of encapsulation, let's see what is in here. Packet in frame. We're going to encapsulate the packet into the frame. Data wrapped in frame, device to device. Inside frame is IP packet. Router determines routing. Okay. Let's see what is the packet routing and let's see what happened exactly. Data goes through the many routers. Okay. Routers strip frame, read the IP address, and create new frame. So when a frame gets into a router, that router is strip that frame, read the IP address, and create a new frame and enhance it to the network and even to another router. So the IP packet remains unchanged and the destination router adds frame with destination MAC. Okay, let's get back in here and NIC driver interconnects the hardware and software. Latest layer that deal directly with the hardware is the layer 3 network. Let's minimize this and open the layer 4 transport. The transport layer, let me do this. Okay. I think it's better in this way. And you can see exactly. Okay. In the layer 4 transport, in this layer, we're going to break data into segments or datagrams. Okay? And organize and send via the NIC and reassemble and verify by receiver. And datagrams are simpler and because they don't have sequence number and in this layer we add the sequencing number to the segment and in this layer we have the disassembler software and in this layer we initiate a request for missing or bad packets. Layer 5, this session handles connecting application to application, manage all sessions for a system, and initiate, accepts, opens, close sessions, and the command to see exactly the sessions, we can use the netscat-a to see that. And let's get to the layer 6 presentation. In the presentation layer, in this layer, we're going to translate data for application layer. Protocols function on multiple layer and encryption protocols like TLS, SSL that initiates in layers 5, encrypt, decrypt in layer 6. And the last layer is the application. Most visible part of the network is the software application. Includes encryption, user authentication, data loop control, and refers to the code in OS, not the application themselves. And OS APIs make program network aware. And the concept that we talk about it in here is encapsulation and de-encapsulation. Encapsulation is the preparing data for networks as info at each layer. And the decapsulation is reversing the previous process, stripping headers at the receiver. That is great. And after we close the OSI 7-layer model, we arrive to the last bullets that we talk about it today. The TCP model, TCP IP model. This model have 4 layers and no standard body for layers, no layer numbers, and let's talk about the layers. Application, transport, internet, link, network interface. We can call it link or network interface. That is interchangeable. Okay, at the first layer, let's talk about the link layer. Link layer that comes and combines the layer 1 and 2 in the OSI model. Includes cabling, hubs, physical addresses, and NICs, deals with the complete frames and transition to the internal layer when frame info stripped. Okay. In the internet layer also called IP packet layer. The IP packets created in here and deals with the pure IP packets. IP addressing is part of this layer and routers functions are in here and doesn't care about data type or order. Transport layer job. This is the job of the transport layer. Okay? So let's see what is the transport layer. In the transport layer, let's talk in this way. This layer combines OSI, transport, session, and some application features, and the assembly of data is in here, and defines connection-oriented and connectionless communications. So, as you can see in here, we can talk about 2 types of connections. First one is connection-oriented. We can name it as TCP, Transmission Control Protocol, and the connectionless, that is UDP, User Data Ground Protocols. Let's see what is they and what are they. The TCP requires connection verification like POP that is used for the main connection and the in the connectionless UDP, we have no verification needed in here, like the voice over IP. And sorry, let's get back in here and let's talk about this TCP segment. Okay, TCP segment contains data after IP address is stripped. Okay, and field in this segment is like checksum, flags, and acknowledgements. In the TCP segment, we're going to ensure the data order, and in the TCP segment, uh, we add port numbers and sequence numbers. And in the TCP segment, we're going to hand the segment to the internet layer for the IP packet creation. Okay, let's talk about the UDP datagram. In the UDP datagram, we're going to add the ports, length, and checksum. After that, in the datagram, UDP datagram, this is the length of the most TCP segment fields and doesn't care if receiver gets data or not. Okay? And let's get back to the application layer. Okay. This layer combines top three OSI layers, handles application initiation, control, and disconnection. And there is a system named port numbering system that is a unique number in this range for each application. OSI presentation layer fits in here, and some exam notes like email uses line format, and APIs make application network aware, as we talk about it in the OSI layer 2. And TCP/IP applications must be part of network function. Okay? And the last one, we talk about the flow and we talk about the encapsulation and layer mapping. Let's at the first talk about the TCP/IP flow, or in other words, encapsulation. Okay. In the application layer, data getting creates. And in the transport layer, chunks data to TCP segments or UDP datagrams. And in the in the internet layer, we're going to, as IP addressing, create IP packets. After that, we're going to, in the link layer, we're going to wrap IP packets in frames, like MAC, FCS, will be added in here. And data ready to wire, okay? Which means we can send data in here. So let's talk about the layer and encapsulation map. We can map link layer to the frame and map internet to the IP packets and map transport to the TCP segment or the UDP datagrams, and we can map the application to data or payload stored and ends in here. Okay, I think we talk about everything in here, and I think it's great for today. And let's see what we can do exactly. I'm going to download this and 10 megabytes. I think it's worth it. And try to open this picture. And okay, that's great. I'm going to rename it to chapter 1 and upload the mind map in the GitHub repository. And there is nothing to say. Let's get back to the full vision. Yeah, there is nothing to say. As you know, I've wrote the chapter 1 and also I wrote, let's show you the chapter 1 of the Linux. So I'm going to record this video about the Linux, but in the Linux, I'm going to talk less and we're going to train with each other each chapter because of the commands we should learn, and I think it's great. So wait for the Linux and I'm going to continue write the chapters and blog posts. Let's get in here. I'm going to wrote the blogs and I think we can structure a comprehensive resource to learn, and I'm very appreciated the that roadmap we are based on it, and I think it's very great. We're going to work with the Pound College. We're going to solve the challenge. We're going to work, and I think everything will be great. And if you have any question, you can ask me in the comments below of this video, and you can reach me via the Discord server. You can reach me via the any other types of the communication that I've prepared. Hope you have a great, great, great day or night, and be successful in your road to be a great hacker. See you in the next video.